Hello everyone, today I'm going to talk about a stable roommate problem. Okay, firstly, what is a stable roommate problem? Well, it is a problem to find a stable matching. In this matching, there is no pair of elements, where both members prefer their partner in a different matching over their partner in the stable matching. It is quite distinct from stable marriage problem because it will match between any two elements, not just men and women. Here is an efficient algorithm for the stable roommate problem. As you can see, this algorithm consists of two phases, phase 1 and phase 2. Basically, after phase 1, we will have a stable subtable of the original table. Okay. Let's have a look at this example to go through the algorithm. Here is an example of 6 unmatched people. They are A, B, C, D, E, F. Each person will order the other members in the group in a preference list. And here is A's list, A's preference list. Okay, let's work on it. First step, A proposes to C, C will accept. B to F, accept. C to B, accept. D to E, accept. E to C, accept. But because C received 2 proposals from A and E, so we need to check E and A in C's list, which is better. Obviously, E is better, and so A will be rejected by C here. So we need to find the next person for A. A proposed to D, yeah, accept. And F proposed to E. That will be rejected because the same in E's list. D is better than F. So we need to find the next person for F. F to A, accept. To make it clear, A to C, reject. That's the 5th step. And C to A, reject. Also 5th step. And F to E, 7th step. E to F, 7th step. Okay, so the above is in line 1 to line 17 in this algorithm. Let's continue. The 9th step is that E to C tells us that C to F will be rejected. That is because C and F cannot be partners in any stable matching. So we do the same thing, C to F and F to C. The same tells us as well, F to A tells A to E. A to E is rejected as well, because F to A and A to F. We need to make sure A is the first element of F. Also, F should be the last element of A, but in this situation, it's not. So we need to eliminate E in A's preference list. Okay, phase 1 is done now. After phase 1, we will have this list, just derived from this. Here becomes phase 2. We will have a cycle, and this is a cycle 1. The PI and QI. According from the algorithm, Q1 is the second preference of P1. Here, that is B is the second preference of A, and C is the last preference of B. As you can see here, C is the last preference of B. So we do the same stuff. A, second B, B, C, and C's second is D, and D's last is A. But if we continue, A's second preference is B, that will be a cycle. So that's why we call a cycle. So we can see here now, like let's look at D to A, that is reject. Okay, good. 11, and A to D, reject 11. The same on B and C. After cycle 1, we have this table. The same stuff here as well. F is A's second preference and B is the last preference of F. The same situation here. And B reject A, E reject D, F reject B. Okay, now after cycle 2, we got this table. That is cycle 3. The same stuff here, and BZB and DE. We reject B, and D is rejected by C. Okay, after cycle 3, we got this. A, F, B, D, C, E, D, B, E, C, F, A. That is done, and phase 2 is over, and we got a stable matching here. But in the stable roommate problem, there is also some counterexample as well. Here is an example that will cause instability, because no stable matching exists if at any point a person is rejected by everyone else. Here, D is rejected by everyone else. Also, the time complexity of Irving's algorithm is big O n square. Thank you for watching.